Okay, so we're proving that a squared plus b squared is greater than or equal to 2ab. How do you think we're going to go about this? What are you going to try and do? Normally with these we're trying to show that it's greater than or equal to 0, okay? So bring that 2ab over. So we're going to be left with a squared minus 2ab plus b squared is greater than or equal to 0. Now to show that that's true, we need to somehow get it to be something to be squared, okay? And we said yesterday we can either do that by completing the square or by showing that it's a perfect square. Now I can see that this is a perfect square, okay? Square root of that number, square root of that number, and then you always take the middle sign, okay? Now you need to check that that works. So I know if this is a perfect square, I'd square the first, a squared, product of the 2 multiplied by 2 minus 2ab, and square the last, b squared. So that is a perfect square. Okay? So you now have a minus b to be squared, which is greater than 0, which is always true. So you can say that this thing is true. Okay? Okay, another example similar to that. If a is greater than 0 and b is greater than 0, prove that a over b plus b over a is greater than or equal to 2. Now, it was really important that they told you a and b were greater than 0. Okay? The reason they did that is because we're dealing with inequalities. Now, normally, if we have something on the bottom line, we need to multiply both sides by the square of it, because that ensures that we don't need to change the inequality sign. But the reason we do that is to make sure that the bottom stays positive. Okay? Now, they're already telling me a and b on the bottom are positive. Okay, so I only come across that issue if it could be negative. In this case, they're both positive. So what I'm going to do is I'm going to get a common denominator here, which is going to be ab. And what did I multiply b by to get ab? I multiplied it by a, so multiply the top by a. And what did I multiply a by to get ab? I multiplied it by b, so multiply the top by b. So normally when we're dealing with inequalities, we'd have to multiply this side by ab to be squared and this side by ab to be squared, because we couldn't be sure that ab is positive. In this scenario, I am sure. A is greater than 0, b is greater than 0, so I can actually just cross multiply like normal. A squared plus b squared is greater than or equal to 2ab, which brings me right back up here. I have the exact same thing. A squared minus 2ab plus b squared is greater than or equal to 0. I know that's a perfect square, so that's always true. So therefore, my question is true. A over b plus b over a is greater than or equal to 2. Any issues with that?
You know where you got a common denominator on the bottom?
Yeah.
The AB. How did you, if you're going from A to AB, would you not multiply it by B? So like, how did you get the A squared and B squared?
Okay, if we think about this as taking two separate denominators. So what did I multiply b by to get ab? So I'm here at b and I want ab.
A.
Yeah. So then if I multiply the bottom by A, I have to multiply the top by A as well.
Oh, okay.
Does that make sense? Yeah? And here I have A and I want AB. So I must have multiplied the bottom by B, so then I also multiply the top by B. So that's where the B squared comes. Okay?
Yeah. Thank you.
No bother. Okay, and just one more example. Okay, show that x squared plus 4x plus 6 is greater than 0. i.e. is positive. So if a question did say to you, show that this x squared plus 4x plus 6 is positive for all values, you need to put in your inequality, okay? So if it's positive, it has to be greater than 0 for all x is an element of or. So I'm going to show this is positive. Now ideally I would like to see if it's a perfect square. So I would square root that number and square root that number. Okay, so not a perfect square. So the other option we have is to complete the square. So this is your formula for completing the square. Okay, so x plus half the coefficient of the x to be squared minus half the coefficient of the x to be squared. So it's going to be x plus 4 over 2 to be squared minus 4 over 2 to be squared plus 6. So that's x plus 2 to be squared. 2 to be squared is 4, so minus 4 plus 6. So we have x plus 2 to be squared plus 2 is greater than 0. Well, that's definitely true because this bit is positive and you're adding on something positive, so that means it's definitely positive. Okay? So true as x plus 2 greater than 0 for all values of x. Okay? Therefore, this thing is true.